Okay, let us discuss the next reaction. So this is again from benzene. So what this problem says, so this problem is something about road map. So this is an easy problem. So let me draw the diagram first. So the problem number we have 17.48. So this is 17.48. So I have benzene. This benzene is treated with AlCl3, and I have a compound something like this, and then COCl. There I have COCl. Product is A, and if A is treated with HNO3, H2SO4, I am getting B. Now if A is treated with ZnHgHCl, this is pretty easy problem. ZnHgHCl, so amalgam zinc, and then I also have HCl. So amalgamated zinc and HCl, this gives C. And C further react with KMnO4, this is hot KMnO4, KMnO4 hot, and conc also. So hot KMnO4 conc, this gives T. This is given. Now if C react with Br2H nu, so Br2H nu, so this means it is something like free radical reaction. Br2H nu, are you getting or not? So this is Br2H nu. This gives E. E when react with tertiary butoxide, that is CH3O3CO, tertiary butoxide CO minus K plus, so this is tert butoxide, it gives Z. And when G reacts with HBr, so when G reacts with HBr, this gives K, H. So he is writing H, so this gives H. Now E reacts with NaOCH3, this gives F, so NaHCO3 gives F. E react with excess NH3, so excess NH3, this gives a compound. So if excess NH3 and the product is given, so you have the product that is given here, so I am getting this product. Here I have NH2, and then I have something like this and this, so this is the final product. We have to write down the ABCD product. So let us try to visualize what will happen. Finally, you have in E react with excess NH3, you have something like this. So this is suggesting there must be a bromine group here. So here must be a bromine group that has been removed because of this NH3. NH3 lone pair will attack and bromine will leave. So this gives me a hint that there must be a bromine here. This also we can verify from here. If I use tertiary butoxide, if I use tertiary butoxide, this is a base, so this will do elimination reaction, so G is alkene. So I am getting some hint, so this alkene, so G looks like this is alkene. And that's why this is further, basically, you see it react with HBr, so this also supports my fact that G is alkene. If it is alkene, it will react with HBr and it will have H plus and Br minus. Now E react with NaHCO3 gives F. So now if you have an alkyl halide, that is a Br is here. Now OHCH3 minus can basically either can act as a nucleophile or it can act as a basically base. Since this seems like alkene, it seems like in this case it will might act as a nucleophile because no heating is given, so it looks like this acting OCH3 might acting as a nucleophile. Now let us see. So the first reaction is very easy. So first one is easy, AlCl the Friedel-Crafts acylation. I will have CO plus and this will react. So the first reaction what will have, I will have this benzene ring is given. So I will make a carbocation. So C, you see here, I can make a carbocation This is basically acylinium ion. So I will make the acylinium ion here. So this is acylinium ion. Acylinium ion. Now this acylinium ion will attack on benzene ring, and I will have the electrophilic addition product O, double bond O, and then I will have this is the product I will have. So this is B, this is very true. Now see, this is A. So I got the product A. Now if I do ZnHgHCl, you see ZnHgHCl, this gives C. So ZnHCl will, what it will do? It will make CO2CH2. So C is very familiar to us. So C is nothing but, so this is CO will convert it into CH2. So this is my C. Now if I do hot KMnO4, everybody knows, in case of hot KMnO4, whatever in the benzene ring, it finally converts into COOH. So D is nothing but, I have to convert everything into COOH. So this is my D. That is because it is reacting with hot KMnO4. Now let us go for here more. So if you see here B, what is B? So B have a ketone, and now this looks like nitration. NH2 plus H2SO4. So this is a nitration reaction. So I can nitrate the benzene ring. So NO2 plus will be generated, electrophile, and now it will do nitration. So B is nothing but nitrated product. So let me write B. So B I can write. So this is my A. Now nitration will happen at meta position because I have a deactivating group. So this is my meta position. So I can nitrate at this position. So this position should be nitrated. So this position I have to nitrate. So let me write, after nitration I will have, so CO, because this is a good basically electron release or electron withdrawing group I have. So that's why it will direct to the meta position, and meta position is this. So I have to add NO2 group. So this is my B, that is the nitrated product. Are you getting or not? So this is the nitrated product I am getting. Now let us go further. So if you have written, you see your copy. I have got B, I have got C, I have got D. Let us say go to the E. This is Br2H. Now this is the free radical halogenation. Now I have C is this. So let us say C. C is this, and now I have to halogenate. Now I have many positions. I can halogenate. I can add a Br dot here, or I can add Br dot here, or I can. Now everybody knows, if I have a benzylic hydrogen, benzylic radical is formed, and in that case Br adds at benzylic position. So in this case Br will add here. So if I add Br dot here, so I will have something like this. I have to add Br here. This is my product E, because I have to add E. Now see, this is also supported by fact that if I excess NH3 is used, I should get this product, and now this product I will get. If I add with excess NH3, this Br goes, so I will have here NH2. So very simple, that is given here. The product is given. Now if I use tert butoxide, so in case of tertiary butoxide, I will have a dehydrohalogenation. So this will go and this will go up. So I will have alkene. So alkene is something like this. So I will have a double bond here, and then something like this, because this hydrogen will be gone and this bromine is gone. So this is my dehydrohalogenation product, that is Z. Now G adds HBr. So HBr if I add, I have to make carbocation here, and H will be here and Br will be here. So I have to add after this. So it will go here. So I have to add Br here, and then I have to add H here, because if I add H here, I will get a carbocation here, and the next step Br minus can attack here. So this is my what is the name? It's H, or this is H. So this is my H. Now only one F I have. So if I am using NaOCH3, NaOCH3, so OCH3 minus on E, so OCH3 minus on E, if reacts, so it will, if it is make an alkene, that is same as Z. So but this is not same, this is a different product. So this means OCH3 minus must acting as a nucleophile. So OCH3 minus will act and Br will go. So if this happens, I will get something like this. OCH3 is here, Br is here. So this is my F. Product F is this. Are you getting or not? So we have already derived all the products. So you just see once again whether are you able to understand or not. So I think you verify yourself. You are getting desired. These are the final product you should get. We'll discuss the next. So this kind of problem usually called roadmap problem. These days these problems are not asked because this problem does not require so much good concept. But earlier days in JEE, people are asking this kind of question. This question does not require a deep concept, does not require a deep understanding of organic chemistry. This requires only overall. So in this question you see, even you don't know the mechanism, you can draw the product. And when I was reading, when I was preparing, I was doing this kind of problem without knowing anything about mechanism. I was not knowing mechanism, but I can do this kind of problem easily because I have remembered all the reactions. But when question these days, this kind of question they does not ask because the actual you can learn organic chemistry only if you know the some mechanism. So mechanism is these days is becoming more and more important. Of course, reaction is important, but mechanism these days is becoming more important. So in future, I think mechanism will be given more weightage, and remembering reaction will be given very less weightage. So you have to remember the reaction, that's correct, but you have to know the mechanism also. We'll discuss the next problem.